Hi, everyone, and thank you for joining us for today's webinar on the race to reduce CO2 emissions, pain points industrial and manufacturing companies face along the way, and how Dataiku's factories, electricity, and CO2 emissions forecasting solution can help mitigate them. The talk will be led by Dataiku's Pierre, AI Solutions Director, Manufacturing and Energy, Romain, Senior Data Scientist, Manufacturing, and Liv, Head of Sales and Partnerships at electricityMap. And I'll turn it over to them to introduce themselves shortly. But for now, we're really excited for today's session that's designed to enable organizations to create a unified and interactive view of their electricity consumption across manufacturing sites in order to optimize their footprint. We hope you find the content valuable as you embark on your own emissions reduction race. My name's Katie, and I work on the content marketing team at Dataiku, and I will be your host for today's webinar. So before I introduce today's presenters, I just wanted to run through a few housekeeping tips and logistics for you to keep in mind. First, the webinar will be shared with you and available in BrightTalk after the presentation, so you will be able to get your own copy of it. Next, we do encourage you to check out the attachment section. We've put in additional materials related to today's topic. The slide deck will also be added to this section so you can reference it after the fact. And finally, please rate the session on BrightTalk. Our team at Dataiku uses the rating, feedback, and comments to inform our future webinars and content. It's really valuable to us, so we greatly appreciate it. And now I'm going to hand it over to Pierre, Romain, and Liv to introduce themselves and kick off the presentation.
Hi, everyone. So I'm Pierre, AI Solution Director at Dataiku, in charge of manufacturing and energy.
Hi, everyone. Happy to be here today. My name is Liv Montmerle. I'm the head of sales and partnerships at electricityMap.
Hello, everyone. I'm Romain Menini, and I'm Senior Data Scientist at Dataiku.
So thanks a lot for the introduction, Katie. So first, present you Dataiku Business Solution. It's a Dataiku initiative to accelerate the delivery of AI project. It's meant to help our customers in their journey to attain everyday AI in their organization. But first, let me introduce you to 4 challenges that we see in during the delivery of value from AI use case. So first, we see that there is a huge roadmap of use cases setting in front of any data science team in any industry when companies open the door to the data and try to start data science projects. The problem is, how do you achieve more and accelerate the speed of the development? The second challenge we see is customization. Each company has its own specificities, its own specific data processes, and no ready-made solution fit all the cases. And if they do it, they will have a lot of constraint, and it will come back to black box solutions that tend to make silos in the companies. The third challenges that we see in the company are coming from a lot of frustration from our customers when they're trying to achieve well-known problems that other companies have already done in their industry. And they ask themselves, is there a way to achieve this use case more efficiently and more quickly? And then the fourth one is that a lot has to be done on common AI projects before tackling the most advanced and mature and futuristic AI use cases. And that's another irritation we could feel. So using the experience we had from our customers and from the industry, we try to find a solution to mitigate those challenges. And our approach is based on 4 different ingredients. Let's have a look at them. So first, we have designed industry solution as a pre-built project. They are pre-packaged project. It means that when using a solution, you get all the elements of data in front of you. All the elements are available. Preparation steps, modeling, AI modeling results, and even the visualization with ready-to-use dashboards and plugins. So time to deployment is reduced to minimum. For instance, in this case, in the distribution spatial footprint, you will be able to leverage a visual web apps of different elements of the flow to quickly deliver from your road of your shop location to visual result that you can leverage in your day-to-day business. So that's the first element. The second element is customizable templates. All the solutions that we release at Dataiku are made entirely of Dataiku elements. It means that you can customize them from the flow of the whole project to the web app that allow you to view the results, the graph, to monitor the performance of your models. In this example of market basket analysis, the solution demonstrates it well. All the different elements that you can see in the flow are modifiable and reusable everywhere. Same goes with the web apps or the graph. The third element is that we have decided to focus on 4 industries: the retail and CPG, manufacturing and energy, financial services, and healthcare and life science. The solutions are built to solve the challenges of one industry, but they can obviously be applied to other industries. And within an industry, we have solutions that follow a certain path of technicity. Some are more short-term and very pragmatic, and some are more long-term and provide really a lot of added value. Then the last pillar of industry solution is our modular structure. The open box nature of our solution allows us to combine, assemble, reuse at wish a lot of possibilities to read projects that you might not even have in your roadmap. For instance, think about your kids that are building with their Legos a nice castle. With industry solution, it's exactly the same thing. You have building blocks that you can combine together to build the roadmap of your future. And here, for instance, I give you the example of in the retail where we have combined together 3 solutions that allow our customers to generate a lot of added value. So just here, we just summarize in 4 key elements what make industry solution. So if we have to summarize, what we can say about industry solution, they are first prepackaged use cases that are entirely customizable and made for specific industries and business function, and allow team to make room for advanced AI use case. But enough with the theory. Let's go and deep dive into our specific solution that we want to talk about today. Factory electricity and CO2 emission forecasting. So why we want to work on this solution? First, it's important to understand that the demand for industrial products has risen considerably over the years. And as such, industrial emission account for 38% of the total CO2 emission in 2020. The energy mix is quite different from country to country, in particular due to the way electricity is generated. And as such, decreasing CO2 emission for industrial company will require a fine-grained and centralized view of all the activities of your company. And first, by trying to reduce the CO2 emission by minimizing the processes in your factory, and then trying to use renewable electricity when it's possible. So if we look at what we want to do, we want to help you to track your global electricity consumption and CO2 emission and forecast them. So what kind of challenges we want to tackle? So first, our customers and many companies have fragmented energy data systems that are unable to measure sustainable progress. We see that reducing emission related to electricity consumption require accurate measurement of CO2 emission content. And it's also difficult to determine the best scenarios to minimize electricity consumption. So the value of the solution that we will present shortly is that we'll centralize the view of your company total energy consumption. Then we have built your electricity metrics and develop a precise CO2 metrics thanks to real-time carbon intensity provided by our partner electricityMap. And we have used AI capabilities to identify the best scenario to reach our sustainable goal. So all in all, we provide a complete electricity consumption from all your factories and instantly assess the greenhouse gas emission of your activities and forecast future emission consumption and associated electricity consumption. So I give the floor now to Liv, who will present you electricitymap.
Thank you very much. And I'm very happy to be here to show you what we do and how this can be complemented with the solutions developed by Dataiku. So at electricitymap, in a nutshell, we organize the world's electricity data. Pierre showed you, and you can see it on the map live on our app, the difference in electricity carbon intensity between different countries. What you can see if you play around with the app is also how that intensity changes from hour to hour, which is why we truly believe in the importance of monitoring your electricity consumption on an hourly level, which we call 24/7, of course. So our app, you can see a screenshot here, is public. We have about 20,000 daily active users, which come organically to see every single day how the intensity in their region is doing. We are very present and very much showcased in a lot of publications, whether they are scientific or press. And we also contribute with a lot of blog posts to the thought leadership and how to minimize carbon emissions from electricity consumption. And we've linked on this presentation, we've linked for all the elements that you can have a look at if you're interested in this. We also participate in shaping emerging regulation, part of a lot of think tanks, but we also know that some ministers in the US, in France, in the European Commission are also using our app to base their understanding on and figure out which policies to set up. Our model is a hybrid open source model. We have already over 2,000 contributions on GitHub. We're one of the most popular climate change projects on there. And we receive contributions from developers and aficionados from almost 100 countries around the world. If we can go to the next slide, I will show you a little bit more about our coverage and our methodology. So currently we cover around 150 zones worldwide. This is part of what makes us the carbon data provider with the widest global coverage. It's a pretty nitty-gritty task that we have set up to do. We get our data from the raw grid data from a multitude of local transmission system operators, ISOs, balancing entities, and any market operator that is most relevant in a market. This is where the open source model is very useful for us because we get contributions from experts who tell us which sources make most sense in their country. And then we factor in the carbon intensity factors from the IPCC report, which is the most scientific, agreed, and peer-reviewed document on carbon intensity factors. We then compute this into average hourly carbon intensity of any grid that we cover on our map. And I will show that later, are able to use our machine learning capabilities to figure out different temporality levels for that. But before changing slides, I just want to clarify what zones are for us. So they correspond to market reality, which is a bidding market, not necessarily a country or a state. And you can research the zones of interest for you directly on our API based on the coordinates that you're interested in accessing. Let's switch to the next slide so I can show you a bit more on the temporality. So we have a multitude of different partners and clients who have many different needs for our data. The most classic need is the need for historical data. We compute the data back to 2018, sometimes even 2015, with an hourly granularity to help you understand, based on the consumption that you have, the historical consumption, what has been the CO2 footprint of your operations in the past. So this historical data is mostly used for carbon accounting, for impact analysis, and kind of figure out the step zero of where you stand. Then we have the real-time data, and this is where a lot more of our machine learning algorithms are coming into play. This real-time data is updated at every hour for all the zones you're interested in. And we even have recently launched an estimation feature, which shows an estimate, which is the most accurate possible data point in case of the source data being delayed or missing, which happens quite a lot. So now with estimations, you always have a data point returned to you, which enables your decisions to be made on a real-time basis without any interruption. This real-time data is mostly used as, so either as Pierre was saying, to optimize and load shift in real time for clients and partners like all of you, but also to integrate into user interfaces. So for example, some of our clients are in the realm of smart home devices, and for them, it's amazing to be able to switch on and off the heat or the machines depending on the grid intensity. Our forecasted data is even more useful for that because it allows, with a 24-hour frame ahead of time, to be able to base decisions of, well, if I'm not doing my activity right now, when can I do it? When will be the best time in the day to do it? So I will go into a specific case, which we are very proud of, and where this forecasted data is being used. Let's switch to the next slide so we can show. Here we have an example of one of our clients. So Google, you probably all know who they are. And as you might be aware, Google has a big electricity consumption linked with their data centers. So here we show a few different examples of how Google is using electricity-map data to reduce their carbon footprint and reach their very, very ambitious target of reaching 24/7 carbon-free energy by 2030. So the first thing, as I mentioned earlier, is using our historical data to perform global assessments of their different data centers around the world. So here they're matching up the consumption of these data centers at an hourly level to the hourly grid intensity of the location where the data center is. Then we work with them on load shifting. So here they forecast the consumption of their data centers, and we forecast the evolution of the grid intensity in the location of the data centers. Matching these two together allows for Google to automate when they want to add intensity to the activities of their data centers and when they need to remove intensity there. And this is how they're able to affect their carbon footprint without any impact on the service given to the end customer. And what is even better is that through these two first steps and through improved carbon footprint of some data center, especially in the zones where there is high reliance on renewable energies, and as you know, the sun shines only certain hours of the day, and the wind is pretty unpredictable. So it's quite good to be able to do this load shifting with a 24-hour ahead forecast. And what happens is that they're now able to allow their Google Cloud users to reduce their footprint by helping them choose the data centers that have the best carbon-free performance and evaluating also the different cloud-related activities that generate different carbon footprint impacts. So their Google Cloud users are now also empowered to reduce their carbon emissions. And this is something we're very proud of having worked on with Google. I will now move to the next slide for another example that we can show. So here we have a more direct example of a use case where electricity-map data is used in consumer interfaces. Microsoft is using electricity-map data to run the automatic updates in the background for their recently launched Windows 11 Insider Preview OS. So right now, this is still in testing for the Insider group, but the feedback so far has been pretty good. and it might get rolled out for all of the Windows 11. So basically what happens is that the automatic updates are scheduled based on the forecast of CO2 intensity, and they run at a moment where it makes most sense, basically when the sun shines most or when the wind blows most. Of course, users are able to force installs if they really need it to happen, right? And now my last slide is a little bit more of an open for discussion and open for imagination. I want to show you a few other spheres in which we start operating more and more. The electric vehicle space is, of course, a very big space for us. We work with numerous auto manufacturers to figure out the future of electric vehicles and make sure that the cars have the ability to manage their charge based on the carbon intensity of the grid, so that they can be a truly green device that also runs on renewable energies and not on fossil. The second space in which we are accelerating right now quite a lot is, as I mentioned before, the smart home device. So allowing at the household level users to be able to do their own load shifting. And this, of course, opens a lot of automation capabilities. And so we're very excited about some of the projects we have going on in that space. And the last one is for all of you around this call, and where we see a pretty big potential, and we've been members, or our data has been used by a lot of hackathons and is in POC with some industrial partners who are trying to see how they can load shift at their level and improve their electricity consumption to match it to times where the grid has the best carbon intensity. So that's it on my side. I will now give the lead to Romain for the demo of how you can make it happen for you.
Thank you, Liv. So yeah, now I will walk you through the demo of how this partnership is actually concretely done in Dataiku. So we have released this solution. Walk you through this solution just after, but a few slides before, of course. In this solution, we have this structured and structured flow, which is typical to DSS project. Actually, we have this CO2 converter I will show you that allows to actually request the electricitymap API, and also a dashboard, which is the main output for the business user, in which you can track the electricity consumption, the carbon emission. So this is in detail the view of what's inside the solution. So the flow, the dashboard, and the CO2 converter. And here is the different flow zone. I will not deep dive in all of them, but globally you start by the left, in which you have the data ingestion part, in which you have all your electricity consumption from several sensors. Generally, the meters are not in the same units or in the same format. So we have the second flow zone, the number 2, which is the data preparation zone, in which you can prepare, adjust your data according to the difference in terms of units or even sensors. The third one is to compute the CO2 emission from the data we have, the electricity consumption we have. The fourth one is if you need to have some view of the price and the electricity price, so the impact in terms of consumption and price of the electricity. The red part, the red flow zone, is regarding the machine learning model. So we have been using our auto model capabilities to train models specific to time series in order to predict the consumption. And finally, we convert again by running several scenarios. So this is the yellow flow zone, in which we are actually, thanks to this pre-trained model, we are forecasting the CO2 emission and the electricity consumption for the site. Now I will just show you the project. So this is a typical Dataiku project. When you are logging to DSS and opening a project, you have some information about timeline, so about activity, who has been done some things on the project. There's of course other view of this in terms of what has been the activity on the project, and you also have a quick reminder of what is the project about. So you can see here some information. Of course, there's a wiki inside each project that you can leverage to add some more information. By the way, in this one, there's a lot of information. As I told you, the main output of this project is the dashboard. So I will go into it right now. So in this dashboard, the first tab is about electricity map, of course, because this is from where we got the data. So this is just the app from electricityMap. So it's interactive. You can click on it, move on it, as Liv just said before. And if you want to deep dive into a country, you have some more information about electricity and also, of course, the carbon intensity, which is the most used feature here in this project. In our case, we are a factory. We have three factories, sorry. And you are actually a central energy expert that is checking the different consumption of the sites. So there are 3 sites. Here you can see it in this meter distribution chart. You have Hamburg, which is in Germany, Évry and Metz are in France. And as you can see, electricity consumption in the center in Metz is consuming approximately half of the electricity, and Hamburg and Évry are about a quarter. Where in terms of CO2 emission on the right, Hamburg is actually 60% of the total emissions, and below you have the same data, but on a different view. It's more over time. So the consumption in electricity consumption and CO2 emission. In the next tab, you have the main consumer per factory. Here we still have this chart to recall that there are several levels of meters. So you have in the factory meters and sub-meters. So for example, if we deep dive into it, you have the main meter, which is counting all the electricity consumption for all the site. But you also have a sub-meter, for example, here it's the main that concern most of the process. So the process consumption, and all the rest is about building, offices and utility. And here if we have the details. So the main A in Hamburg is actually the main consumer. You have the same profile of consumption in Évry, but you can see that in Metz is pretty equal because it's probably some headquarters. So the consumption profile is a bit different. And below, I will not deep dive into this because it's a bit very detailed, but you see that for each month, the consumption for a site. So if we take Évry, you see that here, for example, the offices are consuming more electricity in the winter than in the summer. But for example, here it's the process in blue, and it's more even during the year. With all this data, we have been training some machine learning models. So as I said, everything has been done visually without any code. Here we have just a reminder of the quantity produced per site. And you see that so far, Amber is producing more in tons than the other factories. And I will not go too deep in the details of what the models have been built and what is the metric, but just we have used this metric, which is around absolute error percentage. And we have been training several models, and we see that the best performing model is the feed forward, but we have not been deployed this one. We choose to deploy another one, which is the CNN model, because we wanted to use the external feature to run some scenarios just after. Below, you have just a summary, just to quantitatively show how the model performed in terms of forecasting on the test set. Finally, we have the last tab of this dashboard, which is the scenarios. So we have been using this pre-trained model to run several scenarios, 3 actually. In the first scenario, you have the same level of production overall, but you produce in the same level everywhere. So all the 3 factories are consuming producing the same amount of parts, for example. There is another scenario in which you are producing mostly in France. And the last one is producing mostly in Germany. And you have the impact in terms of CO2 emissions overall here. And you see that there's a big difference if you are producing mostly in Germany compared to mostly in France, or if you are more even in the production plan. So this could be very helpful for our customer to adjust a production plan and to change some things into the production and to be able to run some scenarios to know how it will really actually act on their CO2 emission. And finally, below, it's the same, but you have the consumption and the prediction per month. So it's the same data, but different. Now I will go to the flow to show you how a DSS project look like. So this is basically what you have seen just before in the slides, just for the newcomers to Dataiku. The blue squares are actually the data sets, and the yellow circles are all the visual preparation step, the visual steps. So you have, for example, here it's a stacking, here it's a preparation. And inside, everything is without code. So for example, here we are passing a date just thanks to a smart date tool we have that detects automatically the format of the date. There's a lot of operators in this, for example, so I will not deep dive into it. That's not the topic today. But as you can see, we have not been using here some code, but of course you have some notebooks integration. I personally use the notebook here for the meter distribution, but you can do whatever you want by code, of course. So it's a very good tool for collaborating between different users, between data scientists, which generally prefer to code, and less technical. And here in our example, I would like to focus on the CO2 converter. So we have an example here. So basically the CO2 converter, this is a beta version. It will be updated in the next week, and the idea is to select a date in a data set, a date column, electricity consumption column, and the API provider. Of course, electricitymap is the best to use because it covers many locations, but we also have RTE for France, but it works only if you are in France, of course. So it would not work, for example, in our use case here. So if you have several factories, for example, you will need to use electricitymap. And then, of course, you will need a token from them. And to fill latitude and longitude, this will probably be updated with a geopoint. It's just a little technical detail. And as an output, here, for example, I have in an input just very simple data set with the latitude, longitude, and the electricity consumption for a given date. And as output, electricitymap give us the carbon intensity at that time, and I'm computing the CO2 emission associated to this date. And also date time, because as Liv mentioned before, you sometimes don't have all the dates, even if they are working on it now, it's better. But in the past, you might have some gaps in the. So this is the plugin as it's working so far. The next version of the plugin will include as well the energy mix. So as we have seen on the electricitymap web app, actually, we will recover for a given location, the energy mix. And this is very, very interesting to have more insights on when was the renewable emission, the renewable consumption, for example. So it's very powerful, and thanks to electricitymap, we will be allowed to recover this, which is not, by the way, possible in RTE so far. So we are very pleased to have this partnership with electricitymap, because it allows us to have a lot of information around the data around electricity consumption and CO2 emission. I think this is all I had to show you today, and I'm done probably.
Thank you. Thanks, Romain. That was excellent. Thanks for showing us what it looks like in practice. So what a great session. I want to take this time to thank Pierre, Romain, Liv for the helpful insights on how organizations can move from theory to practice when it comes to reducing CO2 emissions. It's our hope that they will help those in the audience gain an understanding of their footprint and also empower their employees with data, as well as see how Dataiku's solution featuring electricitymap can be an enabler to that success. So as we mentioned, just to close, the recording will be shared with you and the slides will be uploaded in the attachment section. Thank you everyone for joining us today. And once again, we encourage you to leave feedback on the webinar to help us produce content that is shaped towards your needs and interests. And thank you very much to our presenters, Pierre, Romain, and Liv, and stay tuned for more upcoming webinars from Dataiku, and we look forward to seeing you again soon. Thank you.